Hi, my name is Benjamin Drillings, and today I'm going to be covering Lab 5 of Microelectric Technology, covering the rural traffic light in assembly. And the best way to get started on this one is just to jump right in. So here we can see, our code is going to be very similar to that of the urban traffic light, because our urban traffic light is not much different than our rural traffic light, except we're using inputs to control our loop of outputs. Now up here you'll see that we have a bunch of EQUs, and these are all addresses. This is the address that we're going to use for our clock. Notice all of them are 4002. Now this one is different because, well, I'll just show you right now. If I go to page 54, or let's go to 56. Scroll down here. You'll notice that if I'm trying to find the addresses of the GPIOA register which I'm using, I'll notice that they're between 4002, 000 and 4002, 03FF. Now, when we're looking at this code, all of my inputs, outputs, and pull-up resistors that are going to be in my GPIOA register are going to be within that range of values. You know, we're using the least, the lowest, the first number here, right there, that number 4002. That's going to be our mode because that's our first number of that register, and then the rest of it are based off of another part of this, which is around page 156 or 186, 18. Let's go to 187. Perfect. Now notice that our mode register has an offset of 0. Those are the offsets, by the way. These last zeros, these are the offsets, so we know what we're talking about. These are already specified, so the offset for our mode is going to be 0. Our offset for our output is going to be 0.4, and our input is going to be 10. Output is going to be 1.4. Input is going to be 10. And we can see that clearly here. 1.4 and 10. Now, the C is later on. It would take me a little bit to find that, but the C is correct. The C is for our pull-up resistor. And as we look here, we're going to say this is our code. We're going to read it. This is very similar to our last one. This is enabling our clock. Much like our last one, we're going to have this, our GPIOA motor. We're saying the address is we're going to put this value into that address. We're saying that these are the pins that we're going to use, much like here, where we said that we were going to set the mode equal to that number. And we do the same thing here. And then we do the same thing with the pull-up resistors as we did in C. We're saying that our pull-up resistors are going to be equal to 5, and that we can look back at our notes and see that that's because of our, if we look at the bits corresponding, we're going to have 0101, and when we read that as a binary number, we get 5 from that. And then we would get our ODR, which is already starting to get into our actual loop. So this is going to be our actual loop. All of that. That's our actual, our actual command loop. And you can see here that we're pointing to the address. We're setting the address, sending this output to that address, and we're going to read it, store it, and read it. And so it's going to set the output of the register equal to that at this time. And we're going to read this number here, which corresponds with the 210 right there. We're going to read that, and we're going to set our east-west red and our north-south green, which it says in the comments right there. Now, we delay 5 seconds or 5,000 milliseconds, and we get to our big loop. Now, what are we doing here? Well, essentially what we're doing is we're loading our register spot location. We're loading this register with the address here, and then we're loading the least significant bit of R10. I apologize. We're loading R11, this register right here, with the least significant bit of the input. Now, we have an input from our board. Our input, what we want to do is we want to read our least significant bits, which is our PA1 and our PA0. And we want to do that by using this LDRB command, which will read just the last 2 bits. It will only take the last 2 bits of our input and put it into R11. And that's important because we only want to read our last 2 inputs, our least significant input, our least significant bits, the last 2 least significant bits, because those are the ones that correspond with the inputs, and those are what we want to constrain this loop. Now, what we're saying here is that we're going to AND them together. Now, what exactly are we doing by ANDing? Well, that just means we're going to AND one, and we want to AND our least significant bits, our 2 least significant bits together with 2, and then we're going to subtract these. We're going to subtract our least significant bits with the number 2, and if that is equal to 0, then we're going to stay in the loop. Now, why is that important? Well, because if we look at our C code, we can see here that we are ANDing our input with 2, and if it's equal to 2, then we stay in the loop. And that's what we want to do here. We want to keep that the same. So, as you can see here, we're saying that when we AND R11 with 2, R11 has to be equal to 2, which is a command we also state here. R11 has to be, the input has to be equal to 2 for our register to maintain in the loop. And it does so by using here, we're using this while, but how do we remain in the loop when our input is 2? Well, what we do is we use this BEQ command, which says that when this is 0, we loop it. And if R11 is equal to 2, which it should be, to stay in the loop, it will loop, because when R11, which should be 2 to do the loop, is 2, 2 minus 2 is 0, and the 0 will cause this BEQ to make it loop in here. So that is essentially what we're doing there. And then we continue on. We do the same thing again, change state, delay 2 seconds, get to our north-south red, east-west green. Same thing, we address, load it with that output, and move. And then we get back to our second loop, which is doing essentially the same thing as what we did up above, except we're using 1 instead, because if we look here, our 2 least significant bits, the first time we were concentrating on the first one, which is in the 2 spot. But the next one is going to be in the 1 spot, PA0, and that's what the one we want to focus on. And so here, we're doing the same thing except with 1, because when we want, in order to loop this, our PA0 needs to be equal to 1. And if it's equal to 1, then when we AND it with 1, then we can AND it with 1 and put it there. And when we AND it with 1, we should get 1 from it. And so when we do 1 minus 1, we should get 0, which would then cause it to loop. So essentially what we're doing is we are doing the same thing we're doing here. See? We're saying that we're ANDing it together with 1, and we're making sure that it's equal to 1 to maintain the loop. And what are we doing here? We're saying we're ANDing it with 1. We're saying it has to equal 1 because 1 minus 1 is 0 in order to get that 0 to make it loop. Because BEQ reads that 0 and loops it based off the 0. Otherwise, it'll just continue on throughout the code. Then we get another bit over here. We already know, we've already covered, again, what that does here. You know, output, address, output, and store it and read it. Move, and then we loop back up to where it says L1. So this is pretty much it. Again, we've got the truth. I've got the truth tables here. You can see that each state corresponds with the hexadecimal number. In the actual lab itself, I have it here. You know, state 1, state 2, state 3, state 4, all corresponding with these states over here. And if I actually want to show what it looks like, it would be over here. Now, notice it's a little more consolidated due to the fact that I've had to use the other board for another thing. So we have a red here. This is north, south, green, east, west, red. And as soon as I hit that switch, boom, goes green, red, switches. I'm going to move that dip switch back to 0. And now if I wait a couple seconds, I can do the same thing here. Red, boop, boom. So that's all for this lab. I hope this has all been clear. I hope you enjoyed the display, the video. I hope it was informative, and I will see you guys in 2 weeks. Have a good night. Peace.